All right, so this will be our last notes for the week, and everything we've talked about so far will be on your next quiz, including inscribed angles. So earlier, we learned that an inscribed angle was an angle inside a circle whose vertex was on the circle. So you'll see point B here would be the vertex of our angle. And then the two sides of the angle are chords. All right. Inscribed angles, just like central angles, there's a piece of that arc that it intercepts. All right, so this little piece right here, this is its intercepted arc, that little piece. Central angles that we have already talked about, the angle and the arc measures were always equal. With inscribed angles, the degree measure of an inscribed angle is equal to half the measure of the intercepted arc, right? It's half. So this one, first picture is just showing the rule. So if your arc measure is X degrees, then the angle is half of whatever X is. Now you'll see me when I will trace the angle and the arc, makes it kind of look like an ice cream cone a little bit. All right, that helps me visually. So in the second picture, when I look at this, you have to identify that the angle that you're being asked to find is inscribed. So it's going to be half of its intercepted arc. So X would be 65 degrees. Simply take 130, divide by 2. In the third picture, this time you're given the angle and you are asked to find the arc. So now you reverse that. Instead of taking half, we want to double. So we're going to take 53 times 2, and that gets us 106 degrees. Okay. If an inscribed angle intercepts a diameter, remember diameters create semicircles, then the angle is going to always be a right angle because the diameter creates a semicircle that would be 180 degrees. So if I trace that arc and then I drop down this inscribed angle, half of 180 is 90. So the measure of the angle will be half of a semicircle, always. And then the last rule says if two inscribed angles intercept the same arc, all right? So you have two inscribed angles intercepting the same arc, then the angles are congruent. So when I look at this picture, it's asking the measure of angle ABD. ABD, I trace that angle, intercepts this arc right here, arc AD. Well, the other angle that intercepts that same arc is angle ACD. All right, so if they share the same arc, then they will also be congruent to each other. And I hope that makes sense because it doesn't really matter what the arc measure is, both the angles will be half of that number, so they will be the same. All right, so looking at some examples here. Number 1 wants us to find the measure of arc JML. So JML is this arc piece right here. So what I notice in my picture that I have is an inscribed angle that is labeled as 78. So the angle is half, so I'm just going to take 78 times 2, and we're going to get, let's see, 6156 degrees for number 1. Number 2 wants the measure of angle, YXW. YXW, right here's that angle. Remember, pay attention to the markings so that you don't confuse arcs and angles. So this is what we're trying to find right here. I need to know this arc piece, and I don't have it. But I can figure it out because I've got 3 arcs that will create a whole circle of 360. So if I add 88 and 164, that's 252. Subtract that from 360. That's going to be 108. That's the arc piece that's missing. the angle will be half of that. So 108 divided by 2 will be 54. That's my angle. All right, and then our last example wants the measure of arc FE. FE is this little arc piece right here. All right, so let's look at what we have. Well, first of all, I see a right angle, which means that this inscribed angle, the endpoints are part of a semicircle. So this whole arc piece is 180. 65 degrees, this angle is an inscribed angle, so its intercepted arc is going to be double that. So this arc piece is 130. So now, just as we did in the last problem, I've got 180, 130, plus this piece that we want to find, and I can actually call that X, is going to add up to 360. All right, so 130 plus 180 is 310, and then 360 minus 310 is 50, and that's exactly what we wanted. So this would be 50 degrees. All right. I will tell you, it's hard to show work on some of these other than doing the little math on the side, but writing on the picture and tracing on the picture, making those little ice cream cones, noticing where the diameters are to create the semicircles, things like that will help you as you work these problems. Now, there's one last page. All right, now, yesterday we talked about when we had, I guess, a circle that was, or a polygon that was circumscribed. Now we're going to have a polygon that is what's called inscribed. That means it's going to be inside the circle, not on the outside. If a quadrilateral, and this is only works for quadrilaterals, is inscribed in a circle, all right, which means every vertice is going to be on the circle, then the opposite angles, just the opposite ones, are supplementary. So when I look at this picture, I know that the measure of angle A plus the measure of its opposite angle C will equal 180. The other way also works. So the measure of angle B plus the measure of angle D will also be 180. Opposite angles are supplementary. The most common mistake is people think that they should be congruent, and they're not. They need to add to 180. So when I look at problem number 1 and it wants me to find the measure of angle J, all right, it is opposite angle L. So I know that 82 plus, I'll just use J, has to equal 180. So when I subtract that, right, I get 98 degrees for J. To get the measure of angle K, same thing. These are not congruent, they are supplementary. So 55 plus whatever K is needs to equal 180. So we're going to get 125. Simple as that. There are a little algebra in there. Number 2, when I look at this picture, the ones that are labeled are opposite. We are inscribed in a circle. So 94 plus the 9x minus 5 will equal 180. So I've got 9x plus 89 equals 180. Subtract the 89. We've got 91. And then divide by 9. And did I make a math mistake somewhere? Because this will not come out even. Let's see here. Lord knows I've done math mistakes before. All right, so 91 divided by 9. X is going to be 10.1 repeating. Okay. And then number 3, again, wants us to solve for X. So when I look at this problem, I've only given one angle inside my quadrilateral. The angle that I need would be this one right here. So how can I get that? I notice, all right, not really notice, but I know these are all inscribed angles. So if I can figure out what that angle's arc measure is, the whole intercepted arc, then I can take half to get the angle. And I have enough information. They told me the one piece is 94, the other is 134. So that's a total of 228 for the whole arc. So half of that is going to give me 114. So the angle is 114. So now I can do my equation. I know 4x minus 22 plus the 114 should equal 180. All right. So 114 minus 22. We've got 4x plus 92 equals 180. Subtract that from 180. 4x is 88. So x will be 22. And that's what we wanted, was just x. Okay. So inscribed angles today. Use these notes. Let me know if you have any questions.